Saxon Algebra 1, Lesson 37. Welcome to week 11 of our studies. If this is Thanksgiving week, American Thanksgiving, right? For where you are and where you live. And if you have been keeping up with your studies, then we're going to coast a little bit this week. I'm going to give you a break in your homework. There will still be 4 lessons for you to study this week, but because it is American Thanksgiving and because you have been working so hard for 10 long weeks, I am going to edit back the homework. So listen for that at the end. Our topic today is inequalities, and I'm going to start with something that's really earth-shaking. That says 4 equals 4. That symbol in the middle says equals. Who knew, right? And you can probably also conclude this means does not equal. And you can see by my numbers that I'm writing true statements. 4 does indeed equal 4. 4 does not equal 5. Okay, that's straightforward. That's great. What we're going to be talking about is not those two. We're going to be talking about what we call inequalities, which look like this. Right? Or this. And hopefully you learned what those symbols mean back in, like, I don't know, 2nd grade or whatever. But I'm going to remind you, in this one we say 4 is less than, oh, I wrote this one wrong. 4 is less than, right? And this one, here, let me fix it. That one is 5 is greater than. These two are what we call inequalities. They're not equal, and we know it. They're inequalities. Now, when you learn these way back in the day, you probably learned, a lot of you learned some cute little story about a crocodile opening his mouth, eating the bigger numbers. If that's the story you know and that makes sense to you, use it. I'm not an alligator inequality lady, so I won't use that. What I learned is that you start with an imaginary equal sign and then you pinch it so that the opening goes littler on the smaller number side and the opening goes bigger on the larger number side. Some people learned that it points to the smaller number. Whatever way you learned it works for you. I'm going to trust that at this point you know what these symbols mean and how to use them correctly. Now, when we talk about inequalities, we're often talking about a number line. So let's draw one. Our number lines, do not have to be perfect, but they do have to be in good working order so that they make sense. Very often we center our number lines on 0, and then we just mark out some spaces in either direction, counting up on the positive side and down on the negative side. This order is always great. And the reason that that is important is because as we move in this direction, the numbers get greater, right? So as we move -5 compared to -2, number 2 is greater because it's further to this side. And when we go in the other direction, the numbers are getting smaller, or what we say mathematically is lesser, right? We can say big and small, but those aren't mathematically accurate words. So we use greater. The further you go this way, the greater the number. The further you go this way, the lesser the number. So that is useful to us. Let's look at an example and see what kind of problems John has dreamed up for us to do. Here we see x is greater than 2. So our job is to draw a number line that shows all the examples of numbers, all the possible solutions for x that are greater than 2. Okay, so we start with a number line. Now, because we're going to be drawing a lot of number lines, we don't need to put in every detail all day long. This is how I do it. I know 2 is an important number, so I put in 2. I know that I want values for x that are greater than 2, so I know I'm going to be moving in this direction with my solution. Now, here's the tricky thing. We want numbers that are greater than 2. Now, some students might say, oh, well, we start at 3 then, and we count all of those. But what about the little fractions and decimals in between here? Okay, so we need a special symbol that will allow us to suggest we want numbers that are not exactly equal to 2. So we do not want like 2.0000000 and so on. We don't want that number exactly, but we want every number that's greater than that. So for example, we do want 2.0000001, right? We do want that because that's greater than 2. So here's the way we show that. We circle 2. That's our way of saying not exactly 2, but every number, and in this case, it's greater. So an open circle means not that number, but every number greater or lesser, depending on what that is, all right? So this is the solution to our problem. We would draw a number line that looks like just like that. Notice that I have arrows on my number line, and I've circled the number, and this is my solution. I'm saying that any of these numbers can be substituted in here for x, and they will make that come true. I have an open circle because I'm saying not exactly 2, but every tiny little number that's bigger than 2 is included. So this is my solution. This is exactly how I want you to draw your number lines. Be like me. If you want to put in a few other details, if it makes you feel uncomfortable just to have the 2, because really I don't even need the 3. I just drew that because I was talking about it to you. Look at the way I draw my number lines. Make yours the same. If you want to add a few more details, I'm not going to tell you no, but really don't waste your time. Okay, let's try the next example. And let me see, how many examples are there? In this lesson, there are 3. Okay, this time we're asked to, and this is the way John asks the question. He says, draw a number line and graph the solution of, and this time it's x. Okay, this is different. This symbol is a combination of those 2 symbols. It's numbers that are less than, and it's numbers that are equal to. So when we draw our number line, I'm only going to put in this number 2. I want to include 2, right? Because in this case, we said that x can be equal to 2. So this time, I color in that circle. And this time it's less than, so I draw them all this way. All right? So here's what we just learned. We learned that if you color this solid, that means our solution includes 2.0000000 and so on exactly. Okay, so if you have a greater than or a less than symbol, you use a circle on the number line. If you have less than or equal to and greater than or equal to, then you color it in solid. I call this one a circle because it's open, and I call this one a dot because it's closed. All right, that's a very subtle distinction that most students at this point have not seen before. Maybe you had an elementary program that included that idea, but most students did not. All right, so that's an important part of how our knowledge is growing. And then let's do the last one. This is important to remember. And I'm going to ask you in problems, I'm going to say circle or dot. And so you'll look and see, oh, do we include the equals or do we not include the equals? That's a conversation we're going to have a lot. Write an inequality that describes this graph. Okay, I'll draw the picture for you because my book's it's too little in the book. It looks like this. There's lots of other numbers, but there's an open circle at -3, and then there's a line that goes this way. Okay, So we see that our solution does not include 3, so we know it's one of these two. It's an open circle, so it's got to be one of these two. And we can see that it's going to the lesser side, right? So we know that x is less than, not equal to, only less than, because of the open circle, minus 3. That is our answer. Let me just check, because you know, sometimes I do crazy things. That's correct. All right, that is all there is to lesson 37. Now, obviously, we're going to build on this wildly. We're going to be using this graphing for a long time, at least a year. So we'll go over this a million times. This is the part that everybody struggles with. Open circle means that you're not including the exact value. A closed dot means that you are. All right? For your homework, I want you to do, for lesson 37, I want you to do all the practice, and then I want you to do 1 through 15 odds. All right? So you will do problems 1, 3, 5, 7. Let's see, I'm counting them. 1, 2, 3, 4, 5, 6, 7, 8 problems. All right, I'm giving you half of the homework assignment for today's lesson. All right, let me just see. Yeah, that includes a problem from this information, all right? So the practice problems, you'll definitely do all the practice. That will give you a chance to do problems like the one we just did. And then when you do 1 through 15 odd, I see that problem number 7, yes. Problem number 7 is just like this, where John gives you the picture. No, it's like this one, where John gives you the picture and you write the inequality, all right? So I'm cutting your homework assignment in half. You're doing all the practice and you're doing 1 through 15 odd. Technically that's not half because I'm still making you do all those, but I'm doing half the problem set. All right, that's your Monday homework assignment, or whenever you do your homework, right? But that's it. I will see you next time for lesson 38. Thank you, goodbye.